week 4 HGE. Okay, so in this week we'll be discussing about dams and stability of floating bodies, specifically on the fluid mechanics subject. Okay, so to begin with this sample problem, okay, unahin natin yung dam. Assuming that the concrete dam shown weighs 23.6 kilonewtons per cubic meters, the coefficient of static friction that is denoted as mu is equals to 0.23. The intensity of the hydrostatic uplift varies from 20% of the full hydrostatic pressure at the heel to 0 at the toe. Calculate the minimum and the maximum pressure on the soil where the dam rests and factor of safety against sliding and overturning. Okay, so in order for us to calculate the required problems, we have to expose the forces involved dito. Okay? So, ano yung mga forces involved dito? Okay, unahin natin yung hydrostatic pressure. Of course, we have a water here on the left side of the dam. It will create a pressure, no? And the pressure diagram, because of this water, is triangular. Okay? That is because of the formula gamma height. As the height increases, the pressure increases. So this pressure here at the bottom, that is just gamma of the water times 4 meters. Okay? 9.81 times 4. And this will create a resulting hydrostatic force horizontal. Okay? That is just the area of this one. Or we can just simply use the hydrostatic force formula. Okay? But in order for you to see this kind of solution, kaya ito yung ginawa ko. Okay? So, of course, we have to account the weight of the dam. So, we need to calculate first this one. Actually, this is just 6 meters minus 2 meters. That is 4 meters. Okay, so the weight of the dam, so hahatiin natin siya into known polygons. Okay? So, ganito ko siya hahatiin. It depends naman sa inyo. But, for me, ito naman talaga yung pinaka-the best na paghati dito, no? Gawin nating triangle and rectangle. So, let's call this one as W2. And let's call this one as W1. Of course, they will be acting at the centroid of these corresponding polygons. And of course, we should account the water that is projected above that dam. Let's call this one as W3. Okay? Tutulong ito sa stability ng ating dam. Okay. Now, let's define the forces. Okay. So, may analogy pala ako dito. As you can see, the full hydrostatic pressure at heel is 20% to 0 at the toe. So, we need to first to determine where is the toe and where is the heel of the dam. So, ang analogy dito is, okay, so let's imagine this one. Sapatos, no? And Nike shoes, okay. So, if maglalakad yung tao, iikot yan at this point. Okay, so yung point of rotation, yan yung toe. Of course, ito yung heel ng tao. Diba? Okay, so the same lang sa dam. Look at this one. Because of the external force dito, and that is due to this hydrostatic force, it will rotate about this point. Okay, as you can imagine, it will somehow overturn. Pwede siyang mag-overturn because of this force. That's why ito yung magiging toe natin and ito yung magiging heel. Okay, to count this one, may hydrostatic uplift tayo specified sa problem. That means this one will create also a triangular pressure diagram. And this one is 20% of the full hydrostatic pressure, or just 20% of this one. Okay, to 0 at the toe. And of course, this one will also create a resulting force, and let's call this one FU na lang. Uplift force. Okay? Actually, this is just similar to buoyancy. But dito is kino-consider natin yung soil, kumbaga. No? Mag-penetrate yung water natin dito. And we will be having a equivalent pressure diagram dito. But that one or that topic will be discussed on the geotechnical engineering. Okay? And hindi ko alam if aabot ba tayo doon. It depends, no, on our compressed time. I will just compress the topics, probably yung mga common topics talaga natin for board exam. Hindi natin kayang i-discuss lahat. Okay, well, anyway, so weight 1 is gamma times volume. So gamma of the concrete times volume of this one. Okay, 2 times 5 times perpendicular length or 1 meter strip. Okay, actually hindi ko na-specify dito na we should analyze 1 meter strip of the dam. But commonly naman talaga 1 meter strip talaga yan. Okay, 236 kilonewtons. So weight 2, the same, gamma of concrete times this volume dito. Okay, that is a triangle, 1/2 of base times height times perpendicular distance. Okay, now we should also calculate this one, weight 3. So ito, this one can be calculated by similar triangle, no? Considering this whole triangle here, that is 4 meters is to 5 meters is equals to this one is to that one, which is 4 meters. So that is 3.2. Okay, so the weight 3 is just equals to gamma of the liquid, or 9.81, times this volume of this water dito. Okay, that one. Now, the hydrostatic force, 1/2 of base times height, actually the area of this pressure diagram, times the perpendicular distance. Or we can just simply use the hydrostatic formula. Okay, ano ba yung hydrostatic formula natin? Gamma bar H area. Okay, so our gamma, of course, that is 9.81. Bar H is half ng 4. No? That will be acting at the projected dito. Projected area. That is a rectangle dito sa gilid. So, bar H is 2 meters times area, that is 4 meters, times the perpendicular distance to 1. Okay, times 1. So, the same lang yan. 78.48. Okay? I hope you understand this one. Now, the FU naman, the uplift force due to the hydrostatic uplift. So, of course, the same lang yan. Just the area of this one. Gamma bar H 1/2 ito 1/2 of base, ang base natin is 6 meters ito, times height na 7.85 kilopascals, times perpendicular strip na 1, and that is 23.55 kilonewtons. Okay, now take note that yung hahanapin natin is the maximum and the minimum pressure. Okay, so let me just do this one. Okay, so we will be having the reaction dito sa baba, no? Let us call this one as RY. Ito yung mga common notation natin sa mga libro. Okay, so that RY can be solved by summation forces vertical, considering whole forces here, and that will be RY plus this one, upward force, minus the downward forces. Okay, now we can have our RY. Now, after we got this RY, ano pa yung kukunin natin? The overturning moment and also the righting moment. Okay, unahin natin yung overturning moment. Okay, from the word overturn, ano yung magpapa-overturn? So, in this one, that will be clockwise moment. So, ano yung mga clockwise moment dito? That is due to this, the hydrostatic uplift and the hydrostatic force. Okay, overturning moment are the moment that will cause this dam to overturn. Okay, from the word itself, overturn. So, ito lang yun, due to these hydrostatic forces. These forces, the vertical downward force, that will create stability or righting moment. Okay, so iba yan. Unahin natin to, overturning moment. Okay, so we need also to account the moment arms. Okay, since dito tayo mag-moment, we should calculate this one. And that is just, if this is triangle, that is just 1/3 of this height. Okay, or 1/3 of 4 meters. That is 1.33. Also this one, that is 2/3 of this base, or 2/3 of 6. Okay, this is a triangle. Now the overturning moment is just this one, this force times ito, plus this one times ito. Okay, ito yun. Okay, klaro? And we have 198.58 kilonewtons meter. Now, another force we should account is the stability moment, and this is due to the gravity loads. Okay, gravity loads here is the downward forces. So let me just calculate this one. Ano ito? So take note that if this is triangle, yung matitirang distance dito is 1/3 of 3.2. Okay? Therefore, this net distance here is just 6 meters minus 1/3 of 3.2, and that is 4.93. Okay, this one naman. Okay, this one, this is 1/3 of 4 meters. Okay, klaro? Plus 2 meters, and that is 3.33. And this one here, of course, that should be half ng 2 meters. Take note, this is a rectangle, or that is 1 meters. And that's why we can calculate the righting moment. Okay, in this case, that will be counterclockwise. That will be this one times moment arm plus this W2 times the moment arm 3.33 plus this one times 1 meters. And that is the righting moment. Okay, so bakit natin kinalculate ito? Okay, so makikita nyo mamaya. Okay, so let me just call this one as our BARD X. Ito yung mga needed parameters natin to calculate these questions. Okay, BARD X, that is the location of the resultant force Ry dito. Actually, this Ry is just the resultant forces dito. Okay? Yan yung resultant force natin. That should coincide the reaction force dito sa baba. Okay. To calculate the Rx, we should only consider these three forces here. Three reaction forces. Okay, klaro? Tanggalin ko lang yung mga unnecessary forces dito. Ito yon. Okay, so to calculate this Rx, we'll just take moment about this point. Okay, kaya ito na lang yung gagamitin nating mga moments since these are created due to these forces kanina. Ito. Okay, so gagamitin na lang natin to. Ito yung resultant moment nila. Okay, so summation of moment about dito, this one. So as you can see, that will be clockwise moment Ry times BARD X plus the overturning moment minus the righting moment. If we rearrange this one, that's why ito yung formula. Okay, ito yung formula na makikita natin. Or pag ayaw yung mag-memorize ng formula, then you should understand this one. Okay? So, substitute, we have these values here. And that is 2.22 meters. Okay? So, after this one, we should locate the eccentricity. Ano yung eccentricity? That is the offset distance of the reaction force or the resultant force. Ito. So, our eccentricity is measured from the center of the base. If this is B over 2 and this is B over 2, or that is half ng 6 meters no, or 3 meters each, so the eccentricity will be dito yan. From the center to the resultant force. Okay. Okay, so we can just calculate the eccentricity by this one, B over 2 minus this BARD X, since we have our BARD X man. And take note, our B is 6 meters, this total dimension here. Okay, that is 0.78 meters. So actually, our E can be dito rin. Pwedeng lumagpas dito yan. Okay, it depends on the scenario on the given dam. No? Now, after we have this one, okay, gather ko lang yung datas. After we have this one, may dalawang cases tayo to calculate the maximum and the minimum pressure on the soil. Okay. If E is lesser than B over 6, then we have this formula. This is the maximum and minimum pressure na. Okay? Plus and minus yan. And of course, when E exceeds B over 6 or equals, And the maximum pressure is isa lang, negative 2 Ry over 3 bar XL. Okay, wala na tayong minimum pressure dito. Okay? Or minimum pressure dito is 0 automatic, since that will create a triangular pressure diagram dito sa soil natin. Okay? So, i-check natin. Ano yung E natin? 0.78. And ano yung B over 6 natin? That is 1 meters. No? That is 6 meters. Yung B natin, ito, over 6, 1 meters. And that means, hindi siya lumagpas, or we are in this case. Let us call this one as case 1. So, calculating the pressure, siguro gamitin ko na lang yung ating calculator. Okay, so I will just do this formula here. So negative Ry, so variables yung gagamitin ko. Actually, itong L na to, yung L natin dito is just the 1 meter strip. Okay? 1 meter strip lang yan. So hindi ko na lang ito isusulat dito sa calculator. So B. So variables lang yung gagamitin ko, ha? Tapos mag-calc lang ako. Plus 1 plus 6E divided by our B. That one. Okay, so pwede nyo rin gamitin tong style na to, variables, para mas madali na lang. I will just press calc. So Ry represents our Y. Y represents Ry. So 511.23. And then B is this one, the base. That is 6 meters. And E is 0.78. Okay, so we have this maximum pressure plus yan. So negative because pressure only resists compression man. Okay, because of this formula, we just follow this formula. Negative yung lalabas dyan. And kung gusto natin kunin yung minimum, then I will just replace this to minus. Okay, plus or minus man yan, equals that one. Okay, these are the maximum and the minimum pressures. Okay, that one. So if lumagpas yung E natin sa B over 6, that means wala na tayong minimum pressure, maximum na lang. Or actually, yung minimum pressure natin is 0, no? Okay, now the factor of safety against sliding and overturning. So against sliding, we should account the frictional resistance, the maximum frictional resistance dito. So if you remember, on our topic sa friction, we have maximum available friction is mu times the normal reaction. So in this case, that is just mu times the normal reaction is Ry. This is the maximum available friction. Okay? This is not the actual friction. Okay, so in order for us to calculate the factor of safety, we will just equate this one, the friction and the horizontal hydrostatic force. So equating that one, okay, this one, i-multiply natin siya by the factor of safety against sliding is equals to the friction. Okay, ito yung kumbaga magsasabi ilang times natin, ilang times yung kumbaga yung resistance compared sa kanyang moving force. Ito yung magpapamove sa ating dam against sliding, no? So that's why yung makikita natin is mu Ry over the hydrostatic force na formula. Okay, that's one. Okay, so overturning naman. So overturning, from the word moment, equate natin yung moments. So, the overturning moment, this one, i-multiply natin ng factor of safety, equate natin sa Rm. So, ito yung mga resistance. Actually, these are the resistance. Ito, ito. Ito yung magpapamove, this one and this one. I-multiply lang natin sila by factor of safety. Again, in order for us to calculate how many times na mas malakas yung resistance natin. Okay? And, ito yan. Cross multiply mo lang yan. Okay. So, understand? So, maybe we just derive this one. A slight derivation. Okay, so imagine this one. Ito lang yun. Okay. So, the pressure at the bottom between the ground and the dam is bearing pressure actually. Okay, that is just bearing pressure. And ito yung dimensions natin. B and 1 meter strip, no? L. And ito yung contact surface natin between the dam and the ground. Ito yung kino-consider natin na area. Okay, so this is our RY. Actually, hindi siya dito naka-locate sa center, no? But in order for us to transfer this RY to the center, we should account the moment. Ito. And that moment is just RY times E. As you can see, ito, RY times E. Kaya itong result, reaction moment natin dito sa taas. Okay? That is RY times E lang. Now, take note that from the strength of materials or the general principle of the stress, that is just force over area. No? Okay, that's why our stress in this area or the bearing stress is just force Ry over the area. And gagawin natin siyang negative since that is a compressive force na for the soil. No? Negative Ry over the area, that is the length times B. No? And take note, if we have a moment at the neutral axis, no? That is moment about the neutral axis, we should account the bending stress formula, or that is the MC over I. But for rectangular section, we have the right formula, that is 6M over BD squared. No? Kaya ito yung formula natin. Plus or minus 6M over BD squared. So 6 yung moment natin here, yung moment natin dito is Ry times E. B natin dito, okay, so don't misinterpret the formula. BD squared, ang squared natin sa formula is yung parallel sa moment. Ito yung moment natin, parallel sa B. So yung B yung mag-squared dyan. Okay, so rearrange that one. Ito yung formula na ginamit natin lately. Okay? So this one is when E is B over 6. Okay, bakit may limitation ito? Okay, so ganito kasi yan. If this is the case, lesser yung E natin sa B over 6, then we have a trapezoidal pressure diagram dito sa baba. Ito yung Q minimum, ito yung Q maximum. Now, look at this one. Okay, look at the transitions. Ito yung E, ito yung bar X. If this one, the pressure diagram natin dito will be ganito. Let's say nag-zero lang talaga yung pressure dito at the heel, no? As you can see, the transition, the E will be greater or hahaba yung E natin if ito yung scenario natin. Okay, so take note that E is measured from the center to the location of the resultant force. So as you can see here, that is just B over 2 minus bar X. Now, yung bar X natin here should be 1/3 of the base. Take note that if this is a triangle, then this one is 1/3 of the base. Kaya ito yung equation natin. So, it will give us B over 6. Okay. Now, ano yung makikita nyo? If yung E natin, this one, will exceeds B over 6, kumbaga mas hahaba pa siya, that means yung pressure diagram natin dito will be a triangle na lang but wala nang, hindi na siya aabot dito sa heel. Okay? Look at this one. It will somehow ganito because as the E increases, our moment increases also. No? Ry times E. Then it will probably overturn this dam pag ganito. No? As you can see, the transition. Ayun. Okay? Nag-expand rin yung E natin. Then our dam will also overturn. Okay, just an exaggeration. So may if you'll analyze at this portion, hindi na siya magta-touch sa ating soil. Okay, this is just an exaggeration illustration na hindi siya mag-touch dito. Okay, we cannot see this in our naked eye, no, yung overturn dito or yung uplift. So ito, So that's why hindi na siya mag-i-induce ng pressure dito. Kaya sa formula natin, maximum na lang. Ito na yung magiging maximum. Now, how to derive this formula? Okay, so we'll just call this one as our B prime. Okay, this is not the total B na dito. B prime na lang yan. Let's call that B prime. Okay, now take note that this RY, ito, that is just this area times the perpendicular length. So 1/2 of B prime times Q max times the perpendicular length L, no? In this case, that is 1 meters. So okay, take note that part X here, in this case, that should be 1/3 of the B prime. Okay? Now, rearrange that B prime is equals to 3 bar X. Now, if we will substitute this one dito, ito yung formula natin. 2RY over 3 bar XL. Okay? So, this should be negative for compressive. Okay? Well, anyways, hindi naman ito magmamatter sa value na makukuha natin, no? Lalong-lalo na sa board exam, may choices kasi. Okay, so that's why ito yung formula natin. When E exceed B over 6. Okay? I hope you understand that. Okay, so let's try another example. Okay, this one. So, situation 4. Actually, situation 2, no? Okay, situation. The unit weight of the gravity dam shown is 24 kilonewtons per cubic meters. Okay, so calculate the following problems. So we have the mu, 0.5. Okay, so total force exerted by the water on the dam. So that is just the hydrostatic force, no? So if we will look this one at this isometric view, ito yan. Ito yung hydrostatic force dyan. Okay, so we can just simply use the pressure diagram or the formula of the hydrostatic force. Okay, by the way, 1 meter strip yung analyze natin. Okay, part 1. I will just use this one, hydrostatic force formula. So that will be 9.81. The bar H here should be half ng 6, no? That will be acting at the centroid times the area. So, projected area here is 1 times 6 meters. And ito yung hydrostatic force natin. Okay, klaro? Okay, this one. The overturning moment. So, again, yung overturning moment is yung magpapa-overturn sa ating dam. So, in this case, ito lang yun, the hydrostatic force. Walang ibang magpapa-overturn dito. Okay, so anyway pala, so kanina, in the sample problem 1, may hydrostatic uplift tayo, no? Dito, walang nakaspecify na may hydrostatic uplift. So, wala dito. Hindi natin i-account yun. Okay? Okay, so ano yung analogy ng ating overturning moment? Okay, so analyze this one. So, ano ito? This should be, ano to? 1/3 of 6 meters, no? Or that is 2 meters, no? So actually you can just use the eccentricity formula. Okay, so ano yung eccentricity natin? Di ba eccentricity is measured from the centroid of this projected area to the force. So eccentricity is I over area barred Y. So ano yung inertia natin sa ating projected area? Okay, so projected area natin dito is yung rectangular form, no? So you can see kanina. Okay, balik ko lang ha. Ito. That one. Ito yung projected area natin. So let me just calculate the eccentricity. So inertia of this one, that will be 1 times 6 cube divided by 12. Okay, inertia of a rectangle. That one. Ito. Over the area. Area, of course, 1 times 6. Barred Y here is the same lang sa ating barred H since perpendicular, vertical ito. Okay, so barred Y is 3 meters. That is 1. Okay, so take note that this eccentricity is acting from the centroid to this one. Now take note that the centroid here is 3 meters from the bottom. That means yung distance dito, that should be 3 minus 1 or 2 meters. Okay? Well, anyways, pag mga ganitong problem sa dam, automatic na yan, 1/3. 1/3 of base, 2 meters. Okay? So, let's proceed. Overturning moment, ito yung moment na magpapa-overturn like this one. Okay? I hope you can imagine that one. So, this overturning moment, as you can see, that is just this force times this distance 2. Okay? So, we can just calculate this one. And ito yon. Okay. So, part 3. So, part 3, ang hinahanap is the righting moment or the stability moment. So, that one can be calculated due to the weight or yung magpapastable ng ating dam. So, ito yung weight ng ating dam. No? Let us call this one as the weight of the concrete. So, we need to account this distance dito. So, medyo mahirap yan because we cannot directly locate this centroid of this dam natin. No? We can just calculate the centroid by using the Varignon's theorem, no? But medyo hahaba yung solution natin. So, that's why ang gagawin natin is hahatiin na lang natin yung ating concrete into 2 polygons dito. In this case, ganito siya. Okay? Hahatiin natin. So, gagawin ko siyang W1 and W2. Okay? So, first, calculate siguro muna natin yung W1. Yung distances muna. Okay? So, this one, this distance here, 4.2 minus half nito. Okay, take note, this is rectangle. So, half ng 0.6 is 0.3. So, 4.2 minus 0.3 or half ng 0.6, that is 3.9 meters. This one naman, ito, triangle dito. So, this is 2/3 of 4.2 minus 0.6. Okay, yung base natin dito is ito lang. 4.2 minus 0.6 and that is 2.4 meters. Okay, klaro? Now, calculate natin yung W1 and W2. So, generally, yung RM or righting moment natin is W1 times 3.9 plus W2 times 2.4 or that one. So, take note, W1 is gamma of the concrete times the volume. So, gamma is 24 kilonewtons per cubic meters times the volume here, 0.6 times 7 times 1 perpendicular distance. And that is the value. W2 naman, the same approach, gamma times volume. That is the answer. Okay, then we'll just substitute this one dito. Ayun. Okay, klaro? And we have the righting moment. Okay. Now, factor of safety against overturning. Okay, so factor of safety against overturning, as you can remember kanina, that is just RM over OM. Okay, klaro? And that is 3.17 and it is safe, no? Hindi siya bumaba sa 1.0. Okay, so part 5, against sliding naman. Okay, so factor of safety against sliding, of course, ito yung pinakita natin kanina. It will slide, no? At the parallel sa ating ground. Of course, ito yon. The friction over the force. And dito, I just denoted this one as PSL. Yung force na magpapaslide sa ating dam. Okay? Ayun. Parang mag-slide siya ganyan. No? Okay, so let me just go back. So, of course, that friction, we should account this RY. So, RY here is just, klarong-klaro dito, that is, ito, 100.8 and 302.4 lang. Okay? Equate lang natin. Ito yung frictional force natin. That is mu RY. So, mu RY over this one, this PSL is just the hydrostatic force natin. Okay? So, I will just substitute directly this one. Our RY is 101.8 plus 302.4 divided by this one, FH is ito. and we have the factor of safety against sliding. Okay? Okay, I hope you understand this one. So, let's move to the stability of floating bodies. Okay, so stability of floating bodies, actually this is a continuation on the buoyancy topic, na? Because stability of floating bodies talks about if floating body nga, okay? Floating body that is due to the buoyant force, kaya ma-float ang ating dam. I mean, generally yung mga ship, no, magfo-float because of the buoyant force. But here we should also account the tilting, no? As you can imagine, yung ship natin pwedeng mag-tilt because of the wind force and the waves of the water. Okay, so in this case, we should at least know the mga terminologies dito. Okay, so this is called as G. Okay, the center of the gravity. Dito mag-act yung weight. And ito, this is the center of the buoyancy. Okay, and it will be acting to the centroid of the submerged body. Okay, and that is denoted as BO. So ito yung mga iti-take note natin na mga notes or notation. Okay, now, because of the unbalanced force, pwedeng dahil sa wind or dahil sa wave, pwedeng mag-tilt yung ating body, no? So let me just call this one as theta, the angle of tilting. And of course, if nag-tilt yung body natin, the center of the buoyancy will shift. Magsi-shift siya, okay? Because as I have said, the center of buoyancy will act at the centroid of the submerged body. So in this case, it will be somewhere dito. And that is denoted as BO prime. Okay, so actually, yung BO prime, hindi na natin needed na malaman pa to. Ito lang yun, G and BO, yung mga important notations. Okay, so if that is the angle of tilting, the same lang yan dito. Now, if we will project this one, BO to G, connecting that to form a line, and we will project this buoyancy vertically. That one. Okay? Buoyant force is always vertical force. That is upward force, no? So, the point of intersection nila, yan yung tinatawag natin na meta-center. Notation dyan is M. No? So, ano yung significance pag malaman natin yung meta-center? So, ganito yan. If this is the meta-center, that is the point of rotation. If magtitilt yung body natin, in this case, ibabalik siya ng righting moment dito. Ano yung righting moment? If this is our weight, then ito yung point of rotation or the meta-center, then ibabalik siya. As you can imagine, this will be the righting moment, force times this distance. Ayun. Okay? Diyan magro-rotate kung saan ipapastable niya yung ship natin pabalik. And that is what we call the righting moment. Okay? Now, if this is theta, this one is also theta. Then, ito, from M to G, yan yung tinatawag nating metacentric height. Okay? I-take note nyo yan. Metacentric height. Okay, so this one, if we are to consider this right triangle, itong distance nito is just mg sine of theta. Okay, that's why our righting moment can be calculated by this formula. The weight, this weight times the mg sine of theta. Formula na yan. Okay, so main objective natin is to calculate the mg, the metacentric height. So how can we calculate that one? So, by the way, in this case, this will be in stable position. Pag righting moment yung mag-o-occur. Okay? Now, okay, so let us just discuss another situation. Okay, so imagine, if we have a ship, then may cargo tayo, may karga, the center of the gravity will also shift, no? It depends on the form ng ating hindi form. It depends on the weight talaga ng ating material dyan. it will be, for example, it will shift in this position. Now again, if this will tilt, in this case, eto, the same lang sila, no? This will be in unstable position. Okay, again, I will just project this BO to G and the buoyancy vertically. Ito yung magiging meta center natin, no? As you can see, if na-observe nyo kanina, the meta center is above the gravity. Now, in this case, yung gravity natin is above the meta center. Now, ano yung mangyayari dito? Okay, again, I will just project this one. Ito yung magiging moment arm natin. And as you can see, it will create an overturning moment. Okay, this one times this distance. Okay, klaro? Kaya this one is in unstable position. It will make the tilting worse, no? Or ma-overturn talaga yung ating dam dito. I mean, yung ship na LSS ako sa dam. Okay. So, overturning moment, and actually the same lang yan. Yung formula natin sa writing moment. W times mg sine of theta. The same formula lang. Okay? Ang significance nandito, kumbaga yung magiging hint natin if this is writing moment or overturning moment is the location of the gravity. Okay? That is below the meta center, then that is a stable position. If that is above the meta center, then that is unstable position. Okay, so let us just summarize. Ito yon. Okay? For stable position, actually the same lang, no? Writing and overturning moment. Now, the metacentric height, mg, actually, we can just do the, subtract lang tayo. Okay, look at this one. For stable position, the metacentric height here is just mbo from this one up to this point. Okay, mbo minus the gbo. This one up to this one. Okay, so we can calculate this GBO. Okay, makikita nyo mamaya. Now, for unstable position naman, nabaliktad siya. Look at this one. Ito yung main objective natin, to calculate the mg. So, that will be GBO from this point up to this point minus MBO from this point up to that point. Then, we can calculate the mg. Okay? Please understand na lang this one. May formula kasi dito na that is plus or minus. No? And it depends on the case. Well, for me, I just want to understand. Okay? Makikita nyo naman, minus lang talaga. Okay? So, MBO, we have this formula dito. Okay? May formula tayo. For any sections in upright position, that will be I over VD. Okay? For rectangular sections, we can use this one when may tilting na tayo. Okay? Kasi may angle of theta. Okay. So, actually, we can also use this one in upright position. Gawin lang natin theta as 0. Okay? Depends. Now, actually, this one, we can also use this one for non-rectangular sections. Itong term na to, b squared over 12d, that is I over bd. Ito lang yan. Okay? Then, may additional factor lang tayo dito. Okay? So, pwede natin gamitin to for non-rectangular sections. Then, we will just add this factor or multiply this factor. Okay. So, ito. May dalawang tilting. Okay? May dalawang case of tilting. Kumbaga, if this is the length of our shape and this is the base, yung length is the greater length, no? I mean, the greater dimension. So, pwedeng ganito siya mag-tilt. Ano ito yung tinatawag nating rolling, no? It will roll along this long axis niya. Okay, so another case, may tinatawag din tayong pitching. It will rotate along this smaller axis niya. Okay, this is the water surface. Now, actually, yung kadalasan nating ina-analyze dito is yung rolling because mas pabor siyang mag-rotate, no? Or mag-roll about this. Okay, mas pabor siyang mag-rotate in this kind of tilting. Okay, pakita ko lang. Ito. Now, mas madali siya i-rotate pag mas lesser yung dimension dito. Okay, that is just due to the inertia. Okay. So, let's try an example. A rectangular scow, 9.5 meters wide, 14 meters long, and 3.2 meters high, has a draft in water that is 2.4 meters. So its center of gravity is 2.7 meters above the bottom of the scow. So determine the initial metacentric height, the righting or overturning moment when the scow tilts until one side is just at point of submergence. Okay, so this is a board exam problem. Okay, so ito yung scow natin. Okay, let me just call this one as our B, 9.5. And this is the height, 3.2. And ito yung draft natin. So actually, hindi sinate, no? If we will analyze this one as pitching or rolling. But again, mas critical siya mag-roll compared sa pitching. Okay, kaya yung commonly ina-analyze natin dito is rolling. Okay. So, ito yung center of gravity. It is stated its center of gravity is 2.7 meters above the bottom of the scow. So, this is 2.7 above the bottom. Okay? Now, another important notation dito is yung BO, no? Center of buoyancy. And that should be acting at the center of this submerged body. So, the centroid of the submerged body, if this is a rectangular scow, that should be acting halfway nito. Halfway ng 2.4 meters. Okay? Or that is 1.2. Then, as you can see, ito yung GBO natin. Na? Yung magagamit natin to calculate the mg. That is GBO. That is just 2.7 minus 1.2. Okay. Anyways, the initial metacentric height, we should calculate first the MBO. Okay? Metacentric height is mg. So, if sinabing initial, that is in stable position. Wala pa siyang tilting, kumbaga. Okay, so, this is the weight. This is the buoyant force. Then, i-calculate natin yung metacentric height. So, assuming na nasa itaas pa siya. Okay, so we can just prove that. So, we need to calculate the MBO muna. Okay, from this point up to that point. Okay, so by using this formula, kaya wala siyang tilting, mas maiging ito yung gamitin natin. Okay, so ano ba yung inertia to use this one? Inertia is the inertia of the section that is in the plane of water. So in this case, as you can imagine, no, ibalik ko. Ito yon. Ito yung point na nag-submerge sa water. In this case, water interface, kumbaga. No? So, if we will project the cross-section dyan, ito yon. Okay, so ano yung magiging inertia? So, that will be 14 times 9.5 cube divided by 12. Okay, rectangle lang. And ito yung i-cube natin since we are considering rolling. Pag ganyan yung rotation. Okay, about this longer axis. Kumbaga, yung parallel sa moment, yan yung i-cube natin. That one. Divided by the volume displaced or submerged, ito yun. 9.5 times 2.4 times the perpendicular distance na 14 meters. And we have the MBO here. Okay? Now, ibalik ko siya sa plane view. After we got our MBO, then we can just calculate the mg. Okay, so by the way, you can also use this one. Okay, pakita ko lang. B is ito 9.5 squared. Just follow, no? The draft is 2.4. Then gawin lang natin 0 yung theta. So actually, this whole term is 1 lang yan. The same lang siyang lalabas dyan. Okay? Now, mg is equals to MBO from this point up to that point minus GBO. So as you can see, no, our MBO, which is 3.13, that is greater than GBO. Kaya andito sa taas yung M natin. Okay, pag nangyaring mas maliit ito sa ating GBO, then nasa in between siya sa G and BO. Okay, so GBO here is 2.7 minus 1.2. Okay, that's why we can calculate our mg. Ito yung metacentric height, initial metacentric height na wala pa siyang tilting. Now, the righting or overturning moment, di ba? In this case, dapat kunin natin yung metacentric height na magtitilt ng ating body. Okay, so calculate muna natin yung weight, no? Yung weight ng ating scow. So, weight, as you can see, that weight can be calculated by just equating these forces here or just equilibrium, no? Take note, wala tayong SG ng ating scow. So, we can just calculate our weight by equating this one, knowing that we have the volume of this place, no? The weight is equals to the buoyant force, but take note, buoyant force is gamma of the volume times the displaced. That one. So, gamma of the liquid, 9.81 times the displaced volume. That one. Okay? So, don't misunderstand this one. Nakakala nyo, this is the gamma of the scow times the volume of the scow. Okay? Pwede rin. But, hindi binigay dito yung gamma ng scow or SG ng scow. Kaya, we can just equate weight is equals to buoyant force, no? By equilibrium. Now, we have the weight. That one. Now, to calculate the righting moment, again, we will calculate the mg or metacentric height na nag-tilt na siya. Okay, so statement sa problem, when the scow tilts until one side is just at the point of submergence. So, ito yung ibig sabihin niya. Okay, it will rotate in this point. Okay, magsasubmerge lang yung one point natin dito. Okay, so another point of another important thing dito pala, okay, balik ko, magro-rotate yung ating scow at the center dito. Okay, klaro? Magro-rotate siya dyan at the center. As you can see, ito yan. Ito yung point of rotation natin or pivot point. No? So, bakit importante ito? That is because to know the angle of tilting. Take note, walang binigay na specific angle of tilting. So, we can just calculate the angle of tilting considering geometry. Okay? This is a right triangle. So, take note, if we know that this will rotate about the center, then this one is half ng 9.5, no? And this one, ano ito? That is just 3.2 minus 2.4. Okay? So, ito yon. I-project natin BO to G. Okay, actually, hindi nyo na needed na gawin to since alam nyo na yung formula. But, for the purpose of teaching lang, ito yung metacentric height. So, assuming pa rin, no, na nasa itaas, malalaman naman natin mamaya sa mga values natin. So, ito yon. If that is theta, then ito yung theta natin dito. And of course, that is 3.2 minus 2.4 and 0.8. And this one is just half ng 9.5. So, calculate muna natin yung theta natin. That is the arctangent of 0.8 over half ng ating 9.5 or 4.75. And we have these values. No? Then, calculate natin yung MBO in order for us to calculate the MG mamaya. Okay? We will use this formula because may angle of tilting na tayo. Okay, substitute lang. The same kanina but may angle na tayo dito. That is 3.178 meters. And again, we will calculate the MG na. So, as you can see, MBO is greater than the GBO. That means nasa itaas talaga yung metacentric height natin. Okay? So, MG is MBO minus GBO. So, we have the values here. And we have the value of MG. Okay. Now, as you can see, no? Yung M natin is nasa itaas ng W. That means it will create a righting moment or ipapastable niya ulit yung ating ship or scow. Again, this formula, WMG sine of theta, then substitute, we can calculate the righting moment, and that is the value, 872.65 kilonewtons meter. Okay? So, that's it for this week.